Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics and also you can have better understanding of these questions. If you really want to improve your understanding of physics, you just need to focus. When you do past paper questions, you need to focus and do past paper questions, so you will understand question in depth and you will solve in a proper way. And also when you listen these videos, you need to focus, because when we focus on something, we become part of that, we start feeling that thing. So when you study physics, you focus on physics, you become part of learning physics. Then you start feeling physics. When you start feeling something, it means those informations or those actions you are taking at that time, your brain retain them for a long time. So try to develop this habit and then see the effects on your understanding of physics, and also you will see the effects on your life. Let's study together, let's improve together. Question number 11 says a satellite uses two thrusters to adjust its motion in space. Each thruster exerts a force of 40 newtons on the satellite. The line of action of each force is a perpendicular distance of 2.3 meters from the center of gravity of the satellite. These two parallel forces act in opposite directions. What are the magnitudes of the torque and the resultant force acting on the satellite due to two thrust forces? This question is pretty straightforward one. So in this case, you can see we have one thruster here. It is exerting force of 40 Newton. Another one is also exerting force of 40 Newton, but in opposite direction. And the distance from the center of the satellite is given. So the best way to answer this problem is we can redraw this one. So simply I can redraw this line here. And now we can draw the forces on this one. There is a one force that is acting vertically downwards, and there is an other force that is acting vertically upwards. So this is another force. So in this case, we have two forces. So let me redraw this one. So we can redraw this one so it looks proper diagram. So these two forces, they have equal magnitude but they are in opposite directions. So simply I can label this force is 40 newtons and this force is also 40 newtons. And the distance between these two forces is given to us, that is equal to 4.6 meters. 4.6 simply means this is equal to 2.3 plus 2.3. So this is the distance between these two forces. And now if you look at these two forces, they form a couple, and we need to find out torque of a couple, and we need to find out resultant force. So first of all, we can find out F net, means the resultant force. So in this case, resultant force is equal to 0 because one force is vertically downwards and one is vertically upwards. So if I take up is positive, for example, in this case up is positive, so this force will be positive, this force will be negative. So now simply we need to add these two forces. So we have plus 40 and we have minus 40 newtons. So the answer will be equal to 0 newtons. So the resultant force in this case is equal to 0. The second thing we need to calculate is torque of a couple. And torque of a couple, simply you need to understand, this is equal to one force time the distance between two forces, perpendicular distance between two forces. And perpendicular distance in this case we can simply say is equal to d. So let's label this one, this is d, and d is the perpendicular distance. In this case, magnitude of one force we have, that is equal to 40, and we have the distance, perpendicular distance between these two forces, that is equal to 4.6 meters. Now if we solve this one up to 2SF, our answer will be equal to 180. Up to 2SF, you will get answer in this case little greater than 180, but if you write down that one up to 2SF, you will get that is 180. So this is 180 Newton meters. So this is up to 2 SF. Because over given data, this has 2 SF, this has 2 SF. So that's the reason we are using 2 SF in our final answer. So the answer for this question has to be C. So this is the answer. Question number 12 says the diagram show two ways of hanging the same picture. In both cases, a string is attached to the same points on the picture and loops symmetrically over a nail in a wall. The forces shown are those that act on the nail. Very important one, on the nail. In diagram 1, the string loop is shorter than in diagram 2, which information about the magnitude of the forces is correct. So we need to compare T1 with T2 and we need to compare R1 with R2. In order to compare these two forces, simply first of all we can resolve T1 into its components, mean into horizontal and vertical components. So simply we can draw the line here. We can also draw another line here, and the same we can do for T2. So we can resolve into components, vertical and horizontal components. So simply you can first of all complete this triangle. Now in this case you can see it is very clear that this angle, we can say this angle, let's say, is theta 1. So this angle also will be equal to theta 1 because it is symmetrical, and this angle we can say this is theta 2, and this angle also has to be equal to theta 2. Now if we resolve T1 into components, so one component of T1 will be acting vertically downwards and one component will be acting to the left. And if we resolve this T1, one of its component will be acting vertically downwards and one will be acting to the right. So if we resolve vertically, so simply we can say along vertical, R1 in this case, this one has to be equal to 2 times T1. So we can write on T1. So simply we can say 2 times T1 cosine of theta 1, because this component is with angle. And the same we can do for R2. R2 has to be equal to 2 times T2 cosine of theta 2. Cosine, because this component of T2, this is with angle. So this one has to be T2 cosine of theta 2. And we have two components, so that's the reason we have multiply with 2. Simply if you wanna write down in detail, so you can say we have T1 cosine of theta 1 plus we have T1 cosine of theta 1. So in this case these two vertical components are acting vertically downwards and this component is acting to the right and this is to the left. So these two horizontal components, they will cancel each other, but we are only interested with vertical. So now in this case we need to understand theta 1 and theta 2. Theta 1 is greater in this case than theta 2. So we have to compare in this case. If angle increase, so cosine of theta 1 has to be smaller than cosine of theta 2, because cosine is maximum when theta is 0. If theta increase, cosine of that angle decreases. So we can say in this case cosine of theta 1, this is smaller than cosine of theta 2. So now we have to compare tension, but before we compare tension we need to consider R1 and R2. R1 has to be equal to R2, so simply I can write on here. This one has to be equal to R2 because the same picture and same force of gravity that is acting vertically downward. So in this case R1 is equal to R2. If R1 is equal to R2, R1 is equal to R2, so we can write down 2T 1 cosine of theta 1. This one has to be equal to 2T2 cosine of theta 2. If cosine of theta 1 is smaller than cosine of theta 2, so it simply means that T1 has to be, means this one decrease. If this decrease, this part decrease, this one has to increase. So T1 has to be greater than T2. T1 has to be greater than T2 and R1 is equal to R2. Why? Because the same picture is hanging. So the force of gravity acting on this picture is the same. So the answer for this question has to be B. Question number 13 says an object shaped as a hemisphere rests with its flat surface on a table. The object has radius small r and density of the object is rho. The volume of a sphere is given to us, that is equal to 4 by 3 pi r cube. Which average pressure does the object exert on the table? So first of all, we need to understand, in this case, this is a hemisphere. Hemisphere means that this is half of sphere. So this will be the complete sphere. So the complete sphere will be somewhat like this. And in this question, only half of the sphere is given. And the radius of the sphere in this case is given to us, that is equal to r. That is r. So we need to find out P. P simply is equal to force exerted on the table over the contact area, and force exerted on the table in this case is equal to weight of hemispheres. So weight of hemisphere divided by area in contact with the table. Area in contact with the table is equal to area of this circle, means A will be equal to pi r square. So this is the area of circle. And mass will be equal to density of the sphere times volume times g. And in this case, volume of the sphere is given to us, that is equal to 4 by 3 pi r cube. But this is hemisphere, so we have to multiply this one by 1 by 2. So this is the volume of hemisphere, multiply by g, and this is divided by pi r square. So we can rewrite this one. So this is rho, we have 4 pi r cube times we have g, and this is divided by 3 times 2 times pi r square. Now just need to simplify. So in this case, we can cancel this pi with this pi, and we can cancel this 2 with 4, so we will get 2 here, and r square we can cancel with this, so we simply left with rho, and here we have, this is 2, and we left with r, and we have g here, and this is divided by 3. So if we simplify this one, simply we can say this is 2 by 3 rho r g. This is rho r g. So the final answer for this question has to be D. So this is the answer. Simply this is the main concept you need to understand. So this one is main concept. Question number 14 says a probe is used to monitor the quality of the water in the sea. The probe is suspended by a vertical string which is attached to a sphere. The stationary sphere floats in equilibrium on the surface of the sea as shown in the figure. The sphere has a weight of 5 newtons. The probe and the string have combined weight of 2 newtons. The density of seawater is equal to 1.03 times 10 to 3 kgs per cubic meter. The upthrust on the probe and thread is negligible. What is the volume of the sphere below the surface of the sea? Means we have to find out volume of the sphere below the surface. Mean this volume of the sphere we have to find out in this case. But in this case, it is given to us that upthrust on the probe, mean on this probe, and string is negligible. So in this case, simply we need to understand this sphere is in equilibrium. It means the force is acting on the sphere upward. The force mean we can draw the free body diagram. The force acting on the sphere upwards, this force will be upthrust. So this force is simply upthrust, and upthrust in this case has to be equal to the forces acting vertically downwards. So in this case we have two forces acting vertically downwards. One is weight of the sphere, that is equal to 5 newtons, and we have the weight of the probe and weight of the string, and the combined weight is equal to 2 newtons. So 2 newton is acting down. So in this case simply we can write down upthrust, that is equal to upthrust is equal to 7 newtons, and upthrust is equal to weight of fluid displaced. So very important one, weight of fluid displaced. So we can simply say is equal to weight of fluid displaced. So you need to understand the concept, not just use the formula without understanding the concept. So weight of fluid displaced in this case is equal to 7 newton, and weight of fluid displaced is equal to the density of the fluid displaced times volume of the fluid displaced, times g, and this one has to be equal to 7 newtons. And in this case, volume of fluid displaced displaced. This is equal to volume of sphere below the surface is equal to volume of sphere below surface, or we can say volume of fluid submerged in seawater. Volume of sphere we can say below surface. So this is below surface. Now simply we can use the formula. So we can simply use the formula here. So we can say this is Vs. So this is volume of sphere below surface. So we need to find out Vs. So Vs in this case simply will be equal to 7 divided by density of the fluid. So we can rewrite density of the seawater times G. So we have value of density of seawater, that is 1.03 times 10 to 3 multiply by value of G, that is equal to 9.81. Now if we solve this one, our answer should be equal to 6.93 times 10 to minus 4 cubic meters. So this is the volume of sphere below the surface of sea water. So this is how you can figure out. So the answer for this question is D. So D is the right answer. Question number 15 says, what is the center of gravity of an object? So first of all, let's try to understand what is center of gravity of an object. Center of gravity of an object is the point where whole weight of the body may be considered to act. And if we apply upward force, single upward force at that point, that is equal to weight of the object. So we can balance that object. Let's say we have this object. So where is center of gravity of this object? So center of gravity of this object simply you can find out by sliding this finger under this one. So at one point you will see, if you place your finger, you can balance this one. So simply you can see, in this case I can balance this one at this point. So at this point I am applying just single force, and that single force is equal in magnitude but opposite to the weight of this pen. So I can balance that. So this point is the center of gravity where whole weight of the body may be considered to act. So this is center of gravity. If the object is horizontal, center of gravity and center of mass, they lie at the same point. If object is vertical like this, center of gravity and center of mass, they will not be exactly at the same point. It depends on height of the object. If taller the object, the difference between location of center of gravity and center of mass will be greater. If shorter, difference will be smaller. So for this question, simply we need to find out center of gravity. What is center of gravity? Geometric center of the object? No, this is not true. The point at which the weight of the object may be considered to act. Yes, this is correct. The point on the object about which there is a zero net torque on the object. Center of gravity also can be out of the object. So this is also incorrect. The point where gravity acts on the object? No, gravity acts on the object everywhere. For example, if I look at this point, gravity is acting here. Everywhere there is a force of gravity. So this is also incorrect. So the answer is B. Question number 16 says, a system with an efficiency of 74% wastes 230 watts of power. What is the useful output power of the system? Efficiency of the system is given to us, that is equal to 74%. It simply means that wasted output power, we can simply write down wasted P out. Wasted P out, this is equal to 26%. 26% means 26 by 100 times P in. So this is P in. In this case we have wasted P out, that is equal to 230 watts. So simply we can multiply 0.26 with Pn. So when we have value of P in, then we can calculate useful output power. So P in from here, P input we can calculate, that will be equal to 230 divided by 0.26, and this will be equal to 884.6 watts. Now we need to calculate, in this case, useful P out. So we have P in. P in has to be equal to P wasted plus P output, means P useful output, P useful. So this is the output, this is the input. So we have in this case 884.6, and P wasted we have 230, and P useful means useful output power, this one will be equal to about 650. So this will be equal to about 650 watts. So this is our final answer. And so the answer for this question is C. So this is how you can figure out. Question number 17 says a projectile of mass 0.25 kgs is at a height of 30 meters above horizontal ground and traveling at a speed of 15 meters per second. A short time later, it is at a height of 35 meters above the horizontal ground and traveling at a speed of 5 meters per second. How much work is done against a resistance during this time? So simple way to answer this question is we can draw the projectile motion. So this is the projectile motion. So this is how this projectile is moving. So in this case we can take any 2 points because we don't have a lot of information about this. So we can take any 2 points. So we can take 1 point here. Let's say when projectile is here, this is point A, and then after a short period of time projectile is here at point B. When it is at point A, the height of this one is given, that is 30 meters, and the speed is given to us. So we can simply use conservation of energy in this case. Initial energy, this one has to be equal to the final energy. So the initial energy in this case, we have kinetic energy, we can say this is 1/2 m u square plus we can say mg delta h a. This one has to be equal to 1/2, so we can also write down a here. So this has to be equal to 1/2 mv, we can say p square, plus mg delta hp, b delta hp. So ground is our reference point in this case, plus work done against resistive forces, and this work done we have to calculate. So we can write down work done against resistive forces in this case will be equal to initial energy, or simply we can say this is 1/2 mu a square plus we have mg delta ha, means height above horizontal ground when it is at point A, minus we have this is 1/2 m vb square minus we have mg delta hp. Now simply we need to plug in values and we can find out value of work done against resistive forces. So we have 1/2, so we have m, that is equal to 0.25 times we have speed at point A, 15. So we have speed, this is 15 square, and we have plus GPE, that is equal to 0.25 times the mass times the value of G, that is 9.81, times height, that is 30 meters, and we need to subtract 1/2 0.25 times we have the speed at point B, that is 5, so this is 5 square, minus we have height, that is 0.25, means GPE at point B times 9.81 times we have the height, this is 35. If we solve this one, our answer has to be equal to 13 joules up to 2 SF. So this is the final answer. So the final answer for this question is B. So B is the right answer, and this is the work done against resistive forces. Question number 18 says a spring has an unstretched length of 4.50 centimeters. The spring is fixed at one end and a force of 35 newtons is applied to the other end so that the spring extends. The spring obeys Hooke's law and has a spring constant of 420 newtons per meter. We need to find out what is the strain of the extended spring. So first of all, we can sketch so you can see the picture. So we have unstretched spring. So this is unstretched spring, and the length of this spring is given to us, that is L naught. We can say L naught is equal to 4.50 centimeters. This is given in the question. Now we apply force on this spring, and the force we applied on this spring, that force is equal to 35 newtons. So that is equal to 35 newtons. So we can find out new value of L. We can say this is L new. So if we have value of L new, then we can subtract this one, we can find out, but we no need to find value of L new. We can simply find out delta L, because delta L will be equal to force applied on the spring divided by spring constant, means divided by K. So in this case we have F, that is equal to 35 newtons, and this is divided by K. K is equal to 420 newtons per meter. If we simplify this one, we will get delta L is equal to 0.03 meters. So this is value of delta L. Now we have delta L, we need to find out strain, and strain is equal to delta L by L. Delta L is equal to 0.083 and L is equal to 4.50 centimeters, so it means this is equal to 0.050 meters. And if we solve this, in this case our answer will be equal to 1.83. so the value of the strain in this case is equal to 1.85 we will get. If we solve this one, we will get 1.85, so this will be 1.85. If we solve, our answer will be 1.85. So the answer for this question is C. So this is how you can approach this problem. Question number 19 says a wire is fixed at one end and extended by a force that is applied to the other end. The force is slowly increased from 0 and then slowly decreased back to 0. The force extension graph for the wire is shown in this figure. The graph line for the wire being loaded is the same as the graph line for the wire being unloaded. This statement describes the deformation of the wire. So first of all, let me explain you with a simple example. Imagine that if I place my finger on my cheek, you will see my cheek has deformed. Now if I remove the finger, you will see it has regained shape. So it means that this kind of deformation is elastic because my cheek has regained shape, or simply you can say it has returned back to its original shape and size. So this is elastic deformation, and same is happening in this case with the wire, because you can see in this case the final extension after unloading, final extension is equal to 0. So it simply means that this is elastic deformation. We can also understand this one in a little bit different way. Imagine that this is the wire. First of all, we extend this wire up to this point, and then we remove the force, and this wire come back to the original shape and size. So this kind of deformation is elastic. So simply you can imagine you extend the wire, and then when you remove force, slowly force come back to the same shape and size. So that kind of deformation is elastic. So it simply means this is elastic deformation. So the answer for this question has to be B. So the answer for this one is B. If it was plastic deformation, then maybe the graph will look like this. So when you will remove the load, maybe it will end up here, this curve. So in this case, you will see this part, it has extension, means the final length is longer than the original. So it has certain extension. So there is extension. So this will be plastic deformation. So the answer for this question is B. Until now, we have discussed first 19 questions, and I'll be uploading solution of the remaining questions by today or by tomorrow. So I'll see you in next video.